Newton's second law, that's what we're talking about in this episode. We're talking about Newton's second law. Who was Newton? He was a English mathematician, physicist, astronomer, and theologian, and author, widely recognized, Isaac Newton. What did he say about motion? It's so simple. I don't know how you get famous for this one. Every farmer in the world knows this. Everybody that's ever raced a car understands this. It's the law that says if an object accelerates, and first of all, the definition of acceleration is change of velocity or direction of the velocity or the magnitude of it. So if you turn, you speed up, or you slow down, you're changing your velocity. That is because something accelerated you. And what was it that accelerated you? A force. Newton says, Newton's law, the force required is equal to the mass times the rate of acceleration. So whatever. What does a race car driver know? It knows if you want to go faster, you need to have more force and a lighter car. That will accelerate you like a drag racer. If you want to accelerate from 0 to 150 really fast, then you want a large force and a low mass. Lower the mass and a lower air resistance, which is also a force. So we want to accelerate as fast as we can. If you have something stuck, you put a tractor on it, and the tractor's not strong enough to pull it out, what do? Everyone knows. You get a bigger tractor so you can have more force, and that will accelerate it. Will change the velocity from 0 to something, which is what we want. When something is stuck, we want it to not have a 0 velocity. We want to accelerate it out of the ditch or the hole or whatever it's stuck in. If you're a football player, you know about force. If you're standing there and a small force, a little guy runs up to you and knocks into you, it's going to accelerate you in the direction of the force, but only a little bit. If a big guy runs into you, bigger force, it's going to accelerate you in the direction of the force much, much more. So we understand force. We understand Newton's second law. We don't have to make it complicated unless it's for a class. And that brings us to the formula. Newton's second law, the formula is force is equal to mass times acceleration. And what that says is the bigger the force, the bigger the acceleration if mass stays the same. If the force stays the same, as mass goes up, acceleration goes down. If force stays the same, if mass goes down, acceleration goes up. It's just a simple mathematical relationship to express these words. The force required is equal to the mass times the object of acceleration. A good math principle is to rearrange the formula before you plug in. A lot of people will do this. Some people do not. You can just write this into your notebook if you're taking notes on this video. Write this in the three different cases. So if you're finding m, you're going to divide the force by the rate of acceleration. Or if you would rather just memorize one formula, then you can just do the algebra to rearrange it once you get started. Once you've rearranged the formula, the math is really simple. Or you can plug the numbers in first, which a lot of students will do it that way. Find the force needed to cause, example 1. Find the force needed to cause a 5 kilogram object. Find the force. So we are looking for F. Find F where mass is 5 and the rate of acceleration is 20. Write down the formula. Plug in the numbers. 5 times 20. Calculator, or you can do it in your head. F equals 100 newtons. And we have a left up here, so that's going to carry down into a force. What is the mass of the object if we have these conditions? Example 2. Find the mass. What is the mass of the object? What is the mass of the object? What is the mass of the object? Given a force of 20 newtons to the right and a rate of acceleration, which is 4 meters per second, also accelerating to the right. Write down the equation. F equals ma. Plug in the numbers. 20 equals 4 times m. Divide both sides by 4. 20 divided by 4 is 5. 5 kilogram mass, a 20 newton force will result in a rate of acceleration. Or you can do the other way where you rearrange the equation first, plug in the numbers, and divide. Example 3. What will the rate of acceleration be? We're looking for A. We're going to find A. Given that F equals 15 newtons and mass equals 3 kilograms, write the equation. plug in the numbers. 15 equals 3 times a 15 divided by 3, or you can do that thing where you rearrange first. Summary. We understand Newton's law. We understand it. It's not confusing. The bigger the force, the faster it's going to accelerate. The bigger the mass, the harder it's going to be to accelerate that mass. It's harder to push a cement mixer than it is a moped. So, you need more force to make your cement mixer move than you do to make your moped move. Really simple concept. Math is also equally simple. That is it for this episode. Please do all that YouTube stuff where you click, like, and subscribe. Share the video with someone else who may be struggling with Newton's laws, as if anyone struggles with something so simple. That's it. See you in the next episode.